Okay, understood.
Yeah, see, now it is showing recording started, dot, that one. Okay, fine. Go ahead.
Okay. So the first lecture, lecture 1, is about the natural numbers and some operations about that. Operations. Okay, so natural numbers, so basically what are numbers actually for? So numbers actually helps us to keep the count of things, keep the count of things. Okay. So let's say this is a pond and here we have these many fishes. So we can use numbers. This is just showing, for example, so 1, 2, 3, 4, 5. So there are 5 fishes in the pond. Can someone please like say that is my audio clear?
Trainer,
I'm
there
not
is
getting this.
some background noise is coming. In the settings,
Yes.
there is noise cancellation. Okay, in the settings of Telegram.
Okay.
Okay, please switch it on. Something is coming, hissing or some noise. Am I right, Rohit?
Yes, actually.
Yeah,
There was
some disturbance is coming.
Yeah.
Yeah. So,
Is it better now?
maybe.
Is it better
Yes.
now?
Yes, it is better.
Okay. Thank you.
Have you switched the noise cancellation on? Some button is there
Yeah.
somewhere?
Yes,
Okay,
yes,
great.
yes.
Great. Okay, go ahead.
Okay. So, okay. So these are just numbers. So 0 is also a number, but it represents no objects. Okay. So now let's see what are natural numbers. The natural numbers is shown by the alphabet N. Okay? And we can include 0, 1, 2, and so on till infinity. So this means that this goes on till infinity. So what are the natural operations that we can perform? Natural operations are addition, subtraction, multiplication, and division. Okay. So now let's see one thing. Now we have to move forward. Okay, so let's say if I subtract 6 from 5, the answer is -1. Now -1 is not a natural number. So now we need some name which will include all the negative numbers as well. So that we call as integers. Okay. So integers just extend the natural numbers with negative numbers. So now we can show integers as integers is given by the alphabet Z. So this is a standard notation. You can, some other books may refer to something else also. So you need not worry about that. So integer Z is basically from -infinity to positive infinity. Okay. So this is integers. Obviously, we can show this on a number line also. We can create a number line. So I try to create a number line here. Okay. So this means that it is extended towards infinity, and this is extended towards -infinity. In middle, we have somewhere 0, we have 1 on this side, and so on. And on the other hand, we have -1, -2, and so on. Okay. So now, if we see, so what is multiplication? Multiplication is nothing but repeated addition. if I say what is 6 into 2, it is nothing but 6 is added 2 times. Okay. It's equal to 12. If I 7 into 4, this means that 7 is added 4 times. That is 28. Okay. So we can show multiplication as m into n or mn or m dot n. So these are some standard notations for multiplication. Okay. Next, we should know what are cubes and squares. So if m is multiplied by m only once, that is, m is multiplied 2 times, that becomes m squared. Okay. Call it m squared. If you multiply m 3 times, it becomes m cube. This is m cube. Okay, so there is one distinction. 3m is not equal to m cube. Okay, so 3m is in multiplying 3 into the m number, whereas m cube is multiplying m by itself 3 times. Okay? So if we have to multiply m k times, this means m raised to power k, m to the power k. We call it as m to the power k. Okay. Now let's see what is division. Okay, so let's say you have 20 apples and you have your 5 friends. Okay, so what you will do, let's say your friend 1 is this 2, 3, 4 and 5. So this is your 1, 2, 3, 4, 5. What you are doing, so you'll give 1 each. So you'll give 1 apple, 1 apple, 1, 1, 1. Now you have 15 left. Okay, so again you start giving them 1, 1, 1, 1, 1. Now you have 10 left. This way you'll do again, again, again. So now you have 5 left. This, 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 this. Now you have 0 left. Okay, so this means each friend, 5 friends, get 4 apples each. Okay, so let's say if you had only 19 apples.
Actually, there is some noise. I don't know what it is.
Okay, so if someone's,
Is everybody able to hear the same noise?
I'll just mute everyone for now. Oh, I'm not able to mute from here.
I don't know.
Now is it better? I have muted that person.
Yeah.
Okay. Okay. So 19 apples. So what will happen in this last pass? This guy will get only 3 apples. He will not get the 4th apple, right? So this means that what we are doing is 19 divided by 5, we get 3. So this is the quotient. And there is 1 remainder, right? Oh, so 4 will be the remainder. Because these guys got the 4th apple, but this guy did. So this is the remainder. Okay. So basically, what we say is divisor is equal to, we can write it as, we can say 19 is equal to 5 into 3 plus 4. So this is the remainder. This is your quotient. Okay. These are what your the main operators are. Okay. We can also write 19 mod 5. Okay. So whenever you see word mod, it means we want to calculate the remainder. Okay. So 19 mod 5 is basically 4. Okay. Okay. So we say
So
if
we are calling the
B,
mod as a remainder, or
yes,
we are
yes, yes.
calculating the remainder here?
You can say we are calculating the remainder. That is the better thing.
Okay, so when we say 19 mod 5, we are actually, the actual value here is 4, because 4 is what we are calculating here. Which is
Calculating the remainder. Yes.
got it.
So B mod A is equal to 0. Let's say if B mod A is equal to 0, we say that A completely divides B. Okay. Or we can also say B is a multiple of it. Let's take an example. 20 mod 4 will be equal to 0, right? Because it is completely divisible. So we say that 4 divides 20 completely, and 20 is a multiple of 4, right? Because 4 into 5 is equal to 20, right? Okay. So now if you want to find the factor, so what are factors? Factors are just nothing but, let's say if you want to find the factors of 12. So what can be the factor? It will be always in pairs. So 1 into 12 is also 12. 2 into 6 or 6 into 2 is also 12. And 3 into 4 or 4 into 3 is also 12. Okay. So the factors can be always in the terms of pairs. It will be an exception. Exceptions are only the perfect squares. Let us see how. So let's say if you want to find the factors of 25. So 1 and 25, right? And then 5. That's all. So here you can see, because the number repeats itself, right? So here we will have one element, which will have only one element. Otherwise, everything will be in the pairs. Okay.
Okay, so basically when we say this, we are talking about pairing them, or is it that we are saying that we also accept uh, what is this? An exception, which is the perfect square.
I didn't get you. Sorry.
So what I'm trying to say here is when we are doing this, which is 12, which is 1, 1, 1, 12, 2, 6, 3, 4.
Yeah.
So what we are doing here is a pair, but also applies to this is also an exception, which is where, let's say the number is, let's say 25. You're putting 125 and then 5 square here. So that is
Yeah.
also an
Basically,
accepted.
yes. Because so this is an exception, because when in perfect squares, 5 is one such factor which will multiply by itself to get 25, right?
Correct.
So in this, only in the perfect squares, what will happen is that one element will be left. Let's say these are elements 1, 2, and 3. So one element will have only one element. Otherwise, all the elements will have two elements in each.
Okay, so but why can't we use it as 5, 5 in this case?
Because that's the general notation. Because in set
That's
format, when we write this, we don't repeat it. after some 1 or 2 days itself, we'll see in sets, and there are some data structures where we cannot write the same number again. That is the notation of that data structure. That's all.
Okay, so then how do we represent it here? Because here we just put it as 5 and that itself notifies that it is a square in the brackets.
Yes, we'll like you can just represent it as like this. That's more than enough.
Okay,
Yeah.
good. Okay, understood.
So next topic is prime numbers. Prime numbers. So number is said to be a prime number. Number is said to be prime number if it has only two factors. It has only two factors. The factors will be 1 and the number itself. Okay. So let's see 7. Is there any factor of 7? No. 7 can be divided only by 1 or 7 itself. It has no other factor. So we say that 7 is a prime. Right? Let's take another example. Yes. 9. 9 can be represented as 1, 9. It can be represented as 3, 3. So, or we can say 3 itself. Then this is a composite. Okay, so there is one exception here. 1. There is only one factor to this. There is no other factor. So this is neither prime nor composite. Okay. Nor composite. So the rule for a number to be a prime number is that there should be two factors, not less, not more. And those two factors should be 1 and the number itself. That's all. Okay. Okay. So there is one thing that we should know here, that check it. Yeah. So we can. This is known as decomposition into prime factors. We can decompose a number. Decompose a number into prime factors. Let's say you have 12. We can write 12 as, now we don't write 1 here because it's like anything multiplied by 1 will be 1. So we don't write 1 here. So we just write 2 into, okay, let's start from, let's say you don't know anything. So if it is 12, so we can write 12 as 4 into 3, right? Now 4 can be even decomposed, 2 into 2 into 3. Now this can be written as 2 square into 3, right? Let's take another example, 126. So you can write 126 as 2 into 63. Then you can write 63. Let's decompose 63. 2 into 63 can be directly divided by 3. See, like I'm doing it fast because I know that, but you have to just check with some small numbers, but you will be able to do it. So 3 into 21 is always 63. Okay. So now we have got two prime factors. Now let's decompose this part. So we can write as 2 into 3 into 3 into 7. Now these all are prime factors. So we can write this as 2 into 3 square into 7. Okay, so from my side, I've completed lecture 1. If you have any doubts, tell me. Otherwise, we'll move on to the next lecture. That is the rational numbers. Is someone having any doubt? Please let me know.
So let's say we decompose into this 2 square into 3 or 2 into 3 square into 7. Is this what we are trying to achieve? Decompose it to the maximum?
Maximum smallest prime numbers. We are trying to achieve this in this part.
Okay.
Yeah.
But here, 3 square is also a prime in this case?
Because we have already reached 2 into 3 into 3 into 7. So I'm just making it short so it doesn't look very big.
Got it. Okay. Because here what we consider is prime is 2, 3, 3, and 7. Yes, correct. All the three
Yes.
are the
Yeah.
same. But
Yeah.
I mean, is this short?
Just to shorten it. Yeah. Just to shorten it. There might be some questions where you have like options like which will not have so like long, so many things. So it will just square it up. Nothing else. But I'm
But
not
let's say,
writing 3 square is 9. That's the main point. If I write 3 square is 9, then that's the problem.
correct.
Yeah.
Okay. Is
Anybody
this
else?
acceptable notation? 3 square is
Yes,
an
yes, yes,
acceptable
yes, yes.
notation. So,
This is acceptable.
okay.
Anybody else? Okay. So now I'll move on to the next lecture, that is rational numbers. Okay. So this is lecture 2. I don't think so I've written about lecture 1, right? Yes, I've written. Okay. So lecture 2 is rational numbers. Okay. Okay. So we saw that just from recap, just from the first lecture, we saw that when we divide 19 by 5, we don't get a whole, right? Or whatever natural number integer. I don't get that. I get something else. If you know some basic maths, you will know that we can write 19/5 as 3 4 by 5, where 3 is the quotient and 4 is the remainder. So this is what you can write it as. Now the problem is I can say that 3 is a natural number or integer, but how to explain this part? How to write this 4 by 5? So here comes a new number, that is new set of like word we can say, that is the rational, right? So rational number is basically P by Q. Anything in the form of P by Q. There are some rules for this where P and Q are integers. First of all, P and Q are integers. And Q should never be equal to 0. If this becomes 0, then this entire part goes into infinity. Okay, so Q can never be 0. And to represent this, we have a special word Q. Okay. So this is the concept of rational. Okay. So we can, okay, so now there is one fascinating thing about rational number is that let's say 3 by 5, if you multiply this by 2 by 2, it becomes 6 by 10. If you multiply this by 5 by 5, it becomes 30 by 50. So this means that 3 by 5 is equal to 6 by 10 is equal to 30 by 50. Okay. So the uniqueness part is lost now. Uniqueness is lost. Okay. Also, we can like this part that when we know that these are equal, it helps us to add and subtract and actually also compare rationals. Let's say if I'm saying that 3 by 5 plus 3 by 4. Okay. Now it is quite like you have to do. There is one method, traditional method, 5, 4. Okay. So you take the um, least common multiple, then you get 20, then you divide 20 by 5, you get 4. 4 into 3, 12 plus you again divide this 5, 5, 3 the 15. You get the answer 27 by 20. There is better way. What you can do is make the denominators same. How you can achieve it? So 5 into 4 and 4 into 5. Let's do this. And again you multiply denominator same. So this becomes 20, 12 plus 20, 15. Now it is easy, 27 by 20. So this is like this concept of uniqueness when it is lost, it helps us to do these things very easily. So we say this, the proper term is representation is not unique. Representation is not Hmm.
So when you say representation is not unique, so with this example that we saw right now, 3 by 5,
Yeah.
when you multiplied with 2 by 2, you got 6 by 10, then you multiplied by 5 by 5, you got 30 by 50. So when you say uniqueness is lost, what exactly are you trying to say? That where exactly are we talking about that the uniqueness is lost?
We are saying that, let's say this is rational number x, this is rational number y, and this is rational number z. So all these rational numbers are basically equal. This is what I mean.
Okay. Can you please elaborate on this, because I'm not in touch with this for 20 years.
Okay, no problem. No. I'll say with another, I'll take another example. Okay. So now let's see from backside. So let's say I've written 30 by 50. Okay.
Right.
Just a second. Sorry.
I hope I'm not slowing the class.
No. I have something urgent. Just give me a minute. Yeah, I'm sorry. It was extremely urgent. Yeah. Okay,
No,
so Rohit, right? Can you please once repeat your question? We'll start from that place.
so basically, I just wanted to understand
Oh,
this
the
concept of 3 by 5
representation is not unique, right?
representation. Yes, correct.
Yeah. Okay. So let's say this is 30 and 30 by 50. It is quite clear that this is a rational number, right?
Right.
Now, if I, but if you take this like alone, this number 30, is it in the smallest form? Can it be decomposed into more prime factors? Do you
Yes,
think
we
so?
can. We can.
We
We
can.
can.
Okay. So let's try something. I also don't know what is the least. Let's do something random. And I can see 30 is and 50 is there. So I can divide by 5. Okay. So 30 by 5 and 50 by. Okay. So okay. So one point is there. Whenever when you deal with rational numbers, you have to, if you are multiplying or dividing, whatever you are doing, you have to do the same operation with the same number on the numerator side as well as on the denominator side. Otherwise, it will change the number entirely. I just want to keep that number, but in another form. That's the point. So
Okay.
30 by 5 is 6, 50 by 5 is 10. Okay. So this is also a rational number. Okay, no doubt. But
Further do.
I know that 30 by 50 is equal to 6 by 10. There is no difference between these.
Correct.
Okay. Now let's say, is it this number 6? Is it still the prime number? Is it prime number or not?
No, no, no.
No. I can still reduce it, right?
Correct.
So let's reduce this. I just do 6 divided by 2 and 10 divided by 2. See, again the same operation on both sides. So this will
3 by
become
5.
3 by 5.
Right.
Now this is in the least form. Okay. But you know that whatever I did these operations for, it doesn't matter. 30 by 50 is equal to 6 by 10 is equal to 3 by 5.
3 by 5. Correct.
Right? Now, there might be some cases where this might be helpful in calculation, somewhere this might be helpful in calculation, somewhere this might be helpful in calculation. If you want to show 30 by 50 in a decimal format, it is easier to show in this way, right? This is 0.6. But just seeing from 3 by 5, you cannot say in a blink of eye that this is 0.6. But here you can see that this is 0.6. There is no doubt in that, right?
Correct.
So all
Easier,
of them are
easier to
useful in their own way, right?
Got it.
Now, one thing to add here is this 3 by 5 is known as the reduced form of P by Q, which means that P and Q have no common factors. Now, if I'm saying common factor, now see again this will help. I divided 30 and 50 both by 5 because I knew that 30 and 50 both can be divided by 5. Here I divided 6 and 10 by 2 and 2 because I knew that 2 and 2 is the common factor for 6 and 10 both. If you write 6 can be written as 2 into 3 and 10 can be written as 2 into 5, right? Now I know these are the common factors, right? And therefore this is helpful in rational numbers. I hope this part is clear.
This is clear.
Okay. Moving ahead. Okay. Here is okay. So anyone have, I hope all of you would be carrying some notebook or something like that. I ask, this is a small question. Let's say I have given you a rational number 18 by 60. Now give me the reduced form of this. Give me the reduced form. And I hope you guys would do it within 1 minute or so.
So 3 by 10.
6 by 20.
Yeah, great. See, Rohit, right?
Yes.
See, you can just check that can it be reduced further? Is there any, see, just like this part, see, is there any more common factors left? Check.
Yeah, it is. So first is 6 by 20, then I would divide further it by 3 by 10.
Okay,
I just
so
wrote like
this is like, I should clarify that when it is asked reduced form, you go to the least.
Least. Okay, got it.
Yes.
Clear.
Okay, so now moving forward. So this is what, okay, so this is what is known as, so just in saying you learned that this is known as the greatest common divisor or the HCF, highest common factor, GCD or HCF. Okay. So what you did, it is better now. I'll tell you the official way also. So you write 18 as, you can write 18 as 2 into 9. You can also write it as 2 into 3 into 3. So now this is in the least form. Let's take 60. You can write 2 into 30. You can also write it as 2 into 50, 2 into 15. You can write 15 as 3 into 5, right? So it becomes 2 into 2 into 3 into 5. Now write 18 here and 60 here. Okay. So 2 into 3 into 3, 2 into 2 into 3 into 5. Only common thing is 2 is here, 2 is here, 3 is here, and 3 is here. This 3 is there, but 3 is not here because I have already taken it for some other 3. 2 is here, but 2 is not here. This 2 cannot be considered because I have already considered it with this. And 5 is alone. So 2 into 3, which is 6, is the HCF or the GCD. Okay. Now, if you take this 18 by 60, 18 divided by 6 and 60 divided by 6, you reach P by 2, right? Okay. Is this part clear?
Yes, it's clear.
Now, there is one small topic known as dense and discrete. Dense and discrete. When you take a number line, you remember, this is 0 and this is 1. I know that there are many numbers in this, but is there any discrete number within this? I cannot call 0.5 as discrete number. It is basically 1.1 by 2. This is a rational number. Okay. Is there any number between 0 and 1 which I can call as a discrete number? Is it there?
No.
No. So we call that integers, whole numbers, and natural numbers. These all are discrete numbers. Okay. But this is not possible with the rationals. Let's take an example. So just don't think that this is some unit. Just think that this end is 2 by 5 and this end is 4 by 5. Okay. Just for example. Can I have some rational number in between? I can. 2 by 5, 4 by 5 is basically 6 by 5. Right? 2 by 5, 5, yes, 6 by 5. So this can be, and if I divide it by 2, so that is the average, right? I am taking the average between these. So this becomes 3 by 5. So this can be represented as 3 by 5. So, and between this also there can be one more number. That will be 2.5 by 5. Here between also you can have one number which is, so there are multiple possibilities. So therefore we say that rationals are dense in nature. Dense in nature. Okay. Okay. So we have covered natural numbers, operations, and rational numbers. Is there any doubt till this part?
Why are they termed as dense? Is it because they are
Dense, just to show that there can be unlimited rational numbers between any two rational numbers.
okay?
Yeah.
So here we are calling what we are trying to term here is that the discrete. Basically, you're trying to differentiate between dense and discrete, and here discrete is
Yes.
actually whole numbers, natural numbers, or integers.
Yeah, whole numbers, natural numbers, integers are discrete in nature. And till now we have only studied rational numbers, so rational number is dense. So is this part clear? So
Yeah,
I'll
it's
move
clear.
to the last topic for today, is that is real and complex numbers. Real and complex numbers. Okay, so now let's see beyond rationals. Can we write root 2 as in the form of p by q? No, right? Root 2 is basically 1.414 and this is unlimited. This goes, it is never ending, right? If nobody knows the values of root 2, then also I am telling you this value 1.414 and it goes on. Can I write this 1.414 in the form of p by q? No, I cannot, because I don't know where it will end, and I cannot divide it by so many zeros, because I already don't know that this is never ending. So how many zeros will I keep, right? So such numbers which cannot be represented, which cannot be represented in the form of p by q are known as irrational numbers. irrational. Now we have two sets of things. One is rational and another is irrational. So there should be some term to show how, which includes both of these. So that term is known as real number. Real numbers includes both rational numbers and irrational numbers. Okay, and this is represented as R. So rational was Q. Okay. We don't have any notation for irrational numbers because they are just, from the name itself we can see that it is irrational. So there is no proper notation for it. But real numbers we can show that as R. Okay. Okay. So last is left is okay. So there can be like √2, √5, √7. All these are irrational numbers. This we have learned till now. Now there might be some calculation which will result in under root of -1. Now these are not irrational also. These are complex numbers. We'll not study complex numbers. Just I wanted to let you know what is actually complex numbers. So this is just one example. This would suffice. So because that is enough for now. Complex, this much is enough. Okay, so is there any doubt till this part? We have covered 3 lectures today, and if you have any doubt, please let me know. Otherwise, we'll close the session.
Yeah, I just have one question.
Yeah.
Why do we call them real numbers?
There is I also don't know the logic behind that, but the collection of all numbers, rational and irrational, is real.
Okay, understood.
Yeah.
So it's a notation basically.
Yeah, it's a notation, proper notation, that we are just following the official notation.
I don't have any further doubts.
Okay.
And one more student is here, 𝗕𝗲𝗀𝗲. You have any doubt, 𝗕𝗲𝗀𝗲? You joined late. Do you have any doubt? Anything?
Hello.
Yes. Please speak. Any doubts you have?
Miss, I will refer for today and then.
Sure. You refer the today's video and the handwritten notes maybe we will provide you. And after that, you can ask the doubts tomorrow. Okay. In every class, first 10 to 15 minutes will be scheduled for doubt clearance. And after that, the session will start. And the third student,
and I request all of you to please join the session at 6:30.
6:30. Okay.
Yeah.
And if there is any change, sorry sir, just a minute. If there is any change in timings, I'll let you know before.
Okay.
Okay.
And we'll take a poll, like everyone is comfortable with that time, then only I'll make any changes.
Like today we did it. Okay. Yet 3 students have not joined or 2 students have not joined, right? That time everyone was active. No issues. We will send the class recordings immediately within 15 minutes in the respective group. Okay.
Statistics, sir, about it?
Statistics will start tomorrow. Today, computational thinking will start at 9, as I said. Okay. Statistics tomorrow. Okay. And today also, I think there is one session. We will talk it later in the respective groups, not here.
Okay. I'll take your leave, sir. If you want to continue the chat, please continue.
Sure. You have class. Okay. Do one thing. Stop the recording. I think I can stop it from here. 1 minute. 1 minute. Stop the recording.